everyone, Masudi here.
Hi guys, welcome back.
So we had this snippet of code that was waiting there for the customer requests for getting product list and placing order. And I remember that last session we promised that we will first try to refactor this code because it's getting actually ugly and out of control. And then we will continue adding features to this. So this is the customer part. This is the customer application. Almost 70 lines of code and a simple menu like the admin there for just asking for product list and placing order. But also the customer should send the address and customer information about the order. The admin should be able to distinguish between the orders, to see which order goes to whom. And so admin now is just accepting only a single incoming connection, single request. And after that, this thread here, this thread will only run once. It will run from the first line here and it will end here. And it will only accept a single incoming request. After that, it won't accept any further connections. So again, we should, for example, for doing this, we should put this thread into a while true loop. That is
accept more.
Yes, accept as many as thread connections that comes to the admin. But in the reality, when the admin was getting the orders with the phone, a shop might have, for example, only a single or two lines of phone, for example, and simultaneously the shop can get only 2 orders at a time. But with programming, with applications, it can get as many as it needs, as many as the incoming requests. So, but if we don't refactor it and just try to add the feature of having multiple incoming connections requests, it seems that if we see a bug, it will take almost maybe 2 hours, 3 hours, 5 hours, maybe 2 days sometimes to get, to find out what is going wrong there. So we should constantly keep refactoring the code. But I just wanted to, to motivate you to see some features, some funny features, interesting features that a process is connecting to this one, is asking for requests, getting the response. And now that you're motivated, we can refactor, because refactoring is sometimes most of the people try to, evade the refactoring, evade, the refactoring part. But you should constantly keep refactoring your code. So now I want to extract another file, another class, which will, be responsible for the incoming request, which will be the server. So let me just create a new package here. Packages are folders, for let me, for example, say this is the server or admin, or let's say admin package. Packages are folders. If I open this package, open in files, you'll see that it is actually a folder. These are the 5 KD files. This is actually a folder, and these are for organizing your files, your Kotlin files into a category. In programming languages like Java, when you put a class, a file, not a class, a file, into a category, let me just put, for example, create the server file. Now, I'm not going to create the class yet. This is a file. You can see it is writing here package admin. It is telling that, okay, this file is inside the admin package. in programming languages like Java, you are forced to follow the package hierarchy, but the package that you're writing at the top of your file. But with Kotlin, you are not forced to do that, but it is strongly recommended. So for example, you can say I'm in the admin a.b.c. There is nothing wrong with this. And in the other files, in order to access the server file, the things that inside the server file, you have to import admin.a.b.c package to see this file. So the file itself can override the folder hierarchy, and yes, but it is strong. You can see that it is suggesting to package directive doesn't match file location. It is suggesting to match it. So that's the new thing. One new thing, the packages here. Because before that, all the files were in the root package, and they are not inside any folder. And you can see that. Let me get to the top. The first line should be the package, the first line of the code. There is no package line here because they are inside. Yes, they are in the root folder. But now we have an admin, and this is the server, and I want to actually use this server for accepting incoming request and extract these lines of code there. So let's have a class here, class server, and so this server class should be a singleton class. Singleton means that we need only one instance, one object of this class in the lifetime of this application. So we have to instantiate to make it actually instantiated on only once. And Kotlin has a great solution for this, unlike, for example, Java, that you should do it manually. You should make the private, the constructor, and all that. But we'll see. We'll first go with the manual option. So this server class will have the, we will tell, for example, here, let's say, we will say val server equals an instance of the server, which is inside the admin package, you can see. So I instantiated, I create an instance, and then I want to start the server. When I start, and as you can see, there is no function inside the server yet, which this start will actually take this port, for example, and then it will start accepting connections. So let me just cut these lines. Doing refactoring without writing unit tests, without going the TDD style, is absurd. Actually, is not correct. But we'll learn TDD style in along the way. So I cut these two lines, and I Enter, Alt, Enter. I press Alt, Enter on the keyboard. It says create member function. No, I didn't just come here to manually write this. It wrote the function for me here. I get rid of this default implementation, and I paste these lines here. When the server starts, we want to take this port and then keep constantly accepting incoming connection. So we should have some kind of a while loop or something like that. And also, we want to actually listen to the incoming connection somehow. We want to ask the server to notify us when an incoming connection is made, when someone connects to the server. So here, this start is okay, we wrote this. And when someone connects, then we want the input stream and output stream of the incoming connection. So for that, actually, now that we have created a separate class, we want to tell this class to actually please notify us, Your job is to listen for the incoming connections. And I cannot have a while loop constantly asking you whether or not, is there a new connection? Is there a new connection? That is a silly, solution. We should create a solution, follow a solution that makes us available, possible to tell the server to please notify us when an incoming connection is made, when someone has connected, and give us the, for example, input stream and output stream. So because this is the first time that you are seeing the concept of the callbacks. And so inside here, first let's just server, let it be there. So let's say how to do that actually. Let's do it from here. Let's say server dot, for example, server dot notify me. I'm writing these functions. Notify me on new connection. And for this, actually, here, I should be able to pass a block of code, I want to pass a block of code to this function because I want to give a bunch of code, for example, a function to this one to tell it actually, these are the pending actions for you. This is a callback for you. And when you see a new connection, please call me back through this lines of code. There must be a way for me to propose a bunch of lines of code to this notify me on new connection. So different languages have different solutions for that. For example, in object-oriented languages, there are interfaces that we've not seen it yet, and they, for example, write an interface like this. Let me just first go with the interface option, and then we can go with the lambda option. So they write something like this. For example, this is the interface here. You can see, let's say, new connection call back. And unlike classes, interfaces are just the declaration of the functions and properties. So let's say that a callback, a new connection callback, would have something like this. For example, a function, it will be a function, new connection has, for example, been made, or something like this, and passes in stream, which is an input stream, and out stream.
This callback is using for making the connection.
No, this callback will be implemented. You can see that there is no body here. There is no body.
No, I mean that. Why did you make this interface? What was the reason of that?
This will be the bridge between the
server
and the one that is using the server for listening to the incoming connection. Because if we want to listen to the incoming connection, either we have to write all the code here, have while loops, say, okay, now something like the connection came here, okay, I call this function, or the other option is to refactor it, put these lines that are only about listening to the connection, put them inside a separate class. Then, now that we have put them inside a separate class, we don't have access to that class actually to say, okay, when something happened, also execute these lines that I'm giving you. Have execute these 4 lines, 10 lines when for example, someone connected. There is no way to do that, and actually this is the only solution for that. We have to pass an object as a callback to the server and tell it, you as server, please call a function, call a specific function that we both agree on. On this object, that I'm giving you because I've put my logic inside that specific function in this object that I'm giving you. So we have to create a new class, actually, class that has a single or multiple functions, and the caller and the server should be both aware, should agree on the functions and the thing that the function actually takes. And then the caller should, propose, should feed the server with that callback. So, but the logic of this function, because it's going to change every time, because the caller might, for example, write other logic when new connection comes. Because of that, we make it an interface so that it doesn't have any body. So it will take the body when we are creating, when we are passing it as a callback to the admin. So let me just continue here. So let's say this notify me on new connection will accept new connection callback. So for giving the new connection callback, we have to, let's say it is accept. Let me just create this function. Okay, I created it. Let's say it receives a callback of type new connection callback. It will receive an instance, an object of this type. This is an interface, but this is also a type. Like class, it's also a type, but nobody has implemented it yet. So now it is accepting an instance, and say it will call functions on this instance, this object that I'm passing. It will call functions on that to notify me. So I have to put my logic in those functions. So let's say I first, I have to create a concrete implementation of interfaces. So let's say class, for example, my is not a okay naming, convention here. Notify me on new connection. Notify me on new connection. So let's say, okay, my callback extends here is a colon. In Java, we have extends and implements. We can only extend one class, but we can implement as many as interfaces that we want. The same rule also applies here. We can also only extend a single class. But there is no keyword for extend and implements. We have only colon for both of them. And so we are extending the new connection callback. So this class is actually becoming a new connection callback. And it is actually here complaining that there is a function that you have not given any body for that. And we say Control I think, yes. Okay. Now you can see that this is a concrete class because it has all of the functions inside this class has body and has implementation. And the only thing that I have to do is to put my body inside this function. So after the connection is made and we have access to this in and out stream, this is the code that was running there. Let's just cut it there. Let me just cut and paste it here. Okay, so this portion of code was the bit of code that was supposed to run after an incoming connection is made, So after the connection was made, we actually get the input and output stream, and then we were running this part. So we put it in the correct place. So now let's pass this my callback, the instance of my callback here, my callback, and I'm instantiating it. So I create an instance of this callback. I'm passing it as a callback actually to this server. This server now let's get rid of these. Sorry, now the server has this callback has a callback. And when the connection is made, it will call this. It will call the function that we wrote. So it will call these logic here that we have. So let's come here and write the notify me a new connection. So let's say we have to cut this line here, cut it and paste it here. It is actually accepting, so we have to put the server as a field, as a property, sorry, not a field, it's not a field. So I make the server as let's say it's val. Let me just cut and paste it here actually. You know, here I'm just, when we create an instance, all the properties will be, you know, instantiated as well. So this server also will be instantiated. And because this is a blocking code, it's not a good idea to put it there. We want to instantiate the object, for example, in the constructor or here, or when, for example, the user says start. But let's just put it there, you know. Now the start is doing nothing actually, but just let's keep it this way. Now, when the connection is made, we want to first get the in stream of the connection, the socket. So we get input stream, and also we want to get the out stream of the socket, get out stream. And then we want to call back the one that is interested in, you know, this connection. We say callback. Callback is an object, is an instance of that interface. And of course, it has this function that I can call, and I can pass input stream and out stream. So here, my job as a server is to listen for the incoming connection. After a connection is made, then I get the input stream and output stream, and I call back someone that is interested
to
yes.
see the result.
Yes. So this callback is a protocol, is a protocol that we have agreed on, both parties, the server and the client. You know, the client here means that the user of this class, not the customer. So, but there is something wrong with this code also, because it will stop here accepting only once, not only once, but also it will block here, and we don't want that. But let's first get the same result that we have and then refactor more. Okay, here, this part, this is the function that will be called by the server, and this will be passed with the input stream and output stream of the incoming connection. So just these are the, okay, let me just change the names here. Client incoming line is just
input stream.
Yes, is the input stream actually. And client sending line was the output stream. Yes. Then here we are creating a thread for just, yes. I believe that this part, this portion of code will do the same thing, but let's just run it once. Let me run the admin application. You know, the concept of the callbacks will be repeated, you know, a lot, you know. This is the only way of passing a bunch of logic around. We are passing logic to be executed later. So this is the main. Let's run the customer application. Control Shift F10 in the Ubuntu and Windows. Ask for product list 1, and we get the product list and the admin. Yes. Now if we disconnect this customer and we connect again as customer, you know, let's see. If we say, for example, 1 again, nothing will be happen because only a single connection can be made, you know, at this time.
Should disconnect from the previous one.
We should not only disconnect from the previous one, but also we should be able to accept more incoming connections. So this callback here, this callback, I want to actually store it somewhere. Or no, let's just, I don't want to make it complicated to go, you know. So here, let's say we have a while loop, while true. And I put these lines inside this while loop. And after this accepts an incoming connection and gets the input and output stream, it then calls the callback, you know. So now if I run the admin again, let me run it again. And also I run the customer again. One, and then I disconnect as customer. Now the process is killed. I run it again. And if I say 1, I get the same result. And actually, I can make it possible, I can show it that even multiple simultaneous connections can be made to this, and also this will work. So now we have actually refactored a little bit, but it's not ready yet. It's not, you know, okay yet. You can see this ugly part is still remaining here. And also we have this new concept of callback. And so here, let's say when the connection is made, the server gives the input and output stream, and then we actually listen for the incoming data, and then we respond based on the what the incoming request was. So let's get to server, get back to the server. And if I want to actually creating a new class, a concrete class of this interface every single time, just to pass it as a callback is not a good idea. It's not something that is, you know, feasible to do it every time. There must be some way for us to actually create a concrete implementation of this interface on the fly, you know, and pass it to the server as an instance. So for passing as an instance here, this here only accept instances of new connection callback interface. I can say, because it's an interface, I can say I'm creating an object clone from new connection callback, then braces. Then what is the function that I'm overriding? This is the function. So I created an object, an instance of this interface on the fly, you know, without needing this new class. So let's cut these lines. I just forgot one brace there. Okay, I cut this, get rid of these, and I paste them here. So let's again rename this to the names, you know, doesn't matter actually. You can name them whatever you like. So we are now, this is the same code. We just create the object, the callback on the fly. You know, the callback is created on the fly, and other, we can say, for example, other ones can say server dot notify me on object. New connection. Yes, again, object of new connection. This is another callback, for example. This will do other thing, and we can have as many as these as we want. Other parts of the program can access the server and can also notify us when a new connection has been made, for example. And they can give their logic of callback on the fly. They can create it on the fly. So now we have these, but this is not also good, you know. This is the way of doing things in the Java, you know. But Kotlin has a better way of that the lamb does, and we'll see that. So here we have client.server accept input stream, output stream, callback dot. Then we call the callback and we pass the input stream and output stream. if we want to refactor it more, let's see what we can do here. Actually, we can create a protocol here, because socket connections with TCP, TCP connections are when it is connected, when the client is connected to the server, or one peer is connected to the other, they both have an input stream and output stream, which can send as many as data as they want throughout the connection. But this is not the way that we don't want to do this. We want to actually create some kind of protocol here upon this TCP, this socket layer. We want, for example, say when, for example, someone calls the shop, it tells the request and then introduces herself, and then tells asks for the product list, and then tells the request, and then get the response in this format. We are forming the protocol here, and we are trying to move toward the HTTP protocol. I want to move toward that, and so for that, let's say when the new connection is made, we don't want to pass the input stream and output stream to the callback. We want to pass the request to the callback, and we want to actually receive a response and then return it to the one that has been issued the request. So let's create a request here. Let's say we have a request. I created a new class. Let's say this class, the request has, for example, the command name, command title, and let's say this has the val command, which is in string. So because it's a val, either we have to instantiate it right away, or we have to get the value inside a constructor. And we've not seen the constructors yet. Let's write a constructor here. Let's first define the properties. So each request has a command, also has some, for example, parameters. Yes, parameters. Let's say parameters are key values. Let's say parameters are a map of string and string. And then, for example, yes, just let's keep it that way. And here we want to create a constructor. Constructors are, we have called them before, you've seen them. Let me show you, for example. So this is actually a constructor, an empty default constructor that we are calling. So here, let's do this first with server. If we want to pass a port to the server and then start it, we have to either tell it, for example, server dot port equals, for example, 1, 2, 3, 4, 5. But it's not a good idea. If it is nice, it would be very nicer if we could pass it here, for example, say 1, 2, 3, 4, 5. So actually, by passing it here, we are calling the constructor function. We are actually calling another function as well, which is a constructor. And the constructor functions is a special function. In Java, they should be the same name of the class, like server, but here in Kotlin, they should be constructor. It's a keyword here. And let's say we are accepting port, which is an int. So this is a function. There is no return type here because the return type will be an instance of the server, and we don't have to write that. So now it is accepting the port, and we can actually have this port here. Let's say val port of type int, and we can say this dot port equals port. So upon the construction, when we are constructing this class, we are actually also receiving the parameters, and then we construct the instances with those parameters. So this is one way of writing constructors. This is the old-fashioned way, like Java, having properties and fields at the top. We make them private, and then we receive them with the constructor, and we write these lines of code. The better way is actually in Kotlin we have primary constructors, which are written here like this, and we can get the values there as well, but we can also at the same time define them. So I delete these 4 or 5 lines of code, and I replaced it with just this. At the same time, I'm defining the property, and I am receiving it as a parameter of the constructor. So this is the primary constructor. This is named the primary constructor. So I'm just actually here calling a function, the constructor of the server, and that is this line here. And this helps a lot, for writing compact and concise code. Because in Java, when you see the classes, there are a lot of, for example, maybe 20% of the code is just defining the fields and then taking them from the constructor and then assigning them to the fields that we have inside the class. But
so now we don't need to define any constructor.
No, this is the constructor. This is actually the constructor.
It means that it is necessary to import with number, for example.
Yes.
It is necessary.
Yes.
To enter the port.
Yes, this is the necessary one.
We cannot have empty constructor.
We can have secondary. These are the secondary constructors.
If we want to have empty, we should make another one.
This is the secondary constructor. We can, for example, receive other things here. For example, we can receive a string name. But when we have a primary constructor, the secondary constructors should call that with something like this. They should say this, for example, 1, 2, 3, 4, 5. So someone is constructing this class through this constructor, this secondary one, but I should also pass the parameters that the primary constructor needs. This is I can actually receive that. I can receive that and pass it here, like this, for example. You can.
So that is necessary to.
Yes,
call the first constructor.
The primary constructor is necessary one. If you don't write it, this is the empty primary. If you don't write it yourself, override that. This is overriding the primary constructor. If you don't override it, this is actually empty. The primary constructor is empty, and there is no need for actually calling this. There is no need for that. We can get rid of this. Oh, it is forcing us to call the empty constructor. So, so sometimes you need to have multiple constructors, but here we need only one, and we actually define the fields in place. We get them as well. So we have the port. We can use this port to create the server with. We can create the server with that port now. So this is I just wanted to show you, this is the first time that you are seeing the constructors here. I want to use the same concept here, and I want to put these two inside the constructor and define them and also receive them. When someone is creating a request instance of this class, they should call this constructor, this primary constructor, and they should pass these values. So when the class has empty body, we can get rid of this. And you can see that this is actually very pretty and reads well. Unlike Java, for writing the same code inside the Java, you have to write, for example, twice or maybe 1/10 of
lines of code.
as much as lines of code to actually get the same.
They have also setter and getter now.
Yeah, these have setters and getters as well. These have setters and getters. We can make the setter private and all that stuff, and we will see. We can make them var, or we can make the setter private, for example, private set, and all that stuff. So we have a request here. Let's have also response. The response will be success or failure. Let's say I'm creating another class named response. The response will be the command, and then, for example, the failure or the success. Let's say this is this. Let's make the statuses with int as int. So val status int, and also it will have parameters and also a body. Let's say it has a body, which is a string. Make this val as well. Also, the request might have body, val body string. So I'm intentionally moving this, moving toward, I'm refactoring toward HTTP protocol. But step by step. I'm doing that step by step. First, we have a request and a response. So request, or also the response, has the command, which is the command title, and also some parameters and the body. The response also has a status which indicates that whether the response, was successful or not, or something, for example, went wrong. Now the server, actually, we want to refactor this callback and say we don't want to pass this input stream and output stream to you. We want to only pass the request to you, and we are asking for a response. We are asking for a response. So now in server, let's go to the admin application. The admin application will receive only the request here, not the input stream and output stream. It will receive the request let's import it. Okay. And it will return a response. Is it red? Oh, yes, okay. So there is no client incoming line or input stream, output stream now. So now we have only the request and the response. So what do we have inside the request? We have body, command, and parameters. So this is not my job to think how this magic is being, done, by the server. This is the responsibility of the server class to accept the connection, get the input stream and output stream of that connection, then extract all the incoming bytes, put it into a request object, and pass it to me. And then I will create a response and I will return it to the server. And now it is again the responsibility of the server to serialize those content inside the response that I'm giving to, and then return it to the customer. So let's continue for next session, from here. So this is actually, we have in this session learned a lot of things. We have seen, for example, constructors, primary constructors, secondary constructors, defining properties inside the constructors and receiving them at the same time, and also the concept of the callbacks. The only way of passing callbacks is objects. We have to pass instance on an object to someone else and tell it to call in the object-oriented languages, which Kotlin is an object-oriented language and also a functional language. The only way to store a bunch of code somewhere as a pending action and then later passing it around and later call it and execute those lines is just to put it inside an object, inside one of the functions of an object, and store the object somewhere. We can only pass objects in the object-oriented languages, but Kotlin is a functional language as well, and one of the features of the primary features of the functional languages is that makes us available to pass functions around, not objects. So we will see that we'll replace this implementation, this callback, with functions. We will receive functions, we will store functions, we can pass around the functions, we can create new functions on the fly, and yes, we'll see. Yes, so we are here actually moving toward creating an HTTP server, which we will connect with the browser, and you will see that the browser will connect to that and will receive the data, and it will work. This is like, for example, like Apache HTTP server or something like that. Just the smallest, in miniature, smallest in the smallest version, just as much as we need. We need HTTP server only for getting the connection, accepting connection, getting the incoming parameters, and then parse the parameters and then act upon them and return a response just for that. And we will write this portion. So yes, we leave this as read like this, and we will continue the next session.
Thank you.
Thank
for
you.
watching us. Have a good time.
Yes, bye.